Scene script. Have you ever imagined a world where materials can change their shape, function, or properties at will? Welcome to the intriguing world of shape-shifting materials, a realm where the boundaries of reality are constantly pushed, and the line between science and fiction is blurred. This fascinating field of study is part of the broader discipline of adaptive materials science and is propelling us towards a future of endless possibilities. So, let's start at the beginning. What exactly are shape-shifting materials? In the simplest terms, these are materials that can change their physical properties in response to external stimuli such as heat, light, or pressure. This might sound like something out of a comic book, but it's very real and grounded in the principles of material science. The key to shape-shifting materials lies in their molecular structure. Each material is made up of tiny particles known as molecules. These molecules are arranged in a specific way, which gives the material its unique properties. When subjected to certain conditions, these molecules can rearrange themselves, causing the material to change its shape, size, or even its function. Think of it like a dance. Each molecule is a dancer, moving and twisting in response to the music. The music in this case is the external stimulus. When the music changes, the dancers adjust their movements, leading to a completely different dance formation. This is essentially what happens in shape-shifting materials. This incredible ability opens up a world of possibilities. Imagine a building that can change its shape to withstand earthquakes, or a robot that can alter its form to navigate through tight spaces. These are just a few examples of the potential applications of shape-shifting materials. But this is not just about potential. Scientists and researchers around the globe are already exploring ways to tap into the power of these materials. And while there are challenges to overcome, the progress made so far is truly exciting. Clearly, the realm of shape-shifting materials is more than just science fiction. Shape-shifting materials are not magic, but a marvel of science. But how do they work? Let's journey into the atomic world to understand this intriguing phenomenon. Shape-shifting materials, also known as smart or adaptive materials, have the ability to change their form, function, or properties in response to changes in their environment. So, how do they manage this shape-shifting act? The key lies in their microscopic structure. These materials are designed in such a way that their atoms and molecules respond to stimuli like heat, light, pressure, or electricity. When a stimulus is applied, the atoms and molecules rearrange themselves, leading to a macroscopic change in the material's shape or properties. Let's take the example of shape memory alloys. These materials can be deformed, but when heated, they return to their original shape. This is due to a phase change at the atomic level. When the alloy is deformed, the atoms are forced out of their regular pattern. But when heated, the atoms return to their original arrangement, and the material springs back to its initial shape. Then, there are stimuli-responsive polymers, which change their shape or size in response to changes in temperature, pH, or light. These polymers have a network of cross-linked molecules that expand or contract in response to the stimulus, resulting in a change in shape or size. Let's not forget about piezoelectric materials. When pressure is applied to these materials, they generate an electric charge. This is due to the alignment of positive and negative charges within the material, which changes when the material is deformed. The opposite is also true. When an electric field is applied, the material changes shape. These examples illustrate the fascinating world of shape-shifting materials, where atoms and molecules dance to the tune of external stimuli. The science behind these materials is a complex blend of chemistry, physics, and engineering. It's a realm where materials are not just passive recipients of forces, but active participants, adapting and changing in response to their environment. So, the secret behind shape-shifting materials is a blend of chemistry, physics, and a dash of engineering. Now that we understand how shape-shifting materials work, the question arises, where can we use them? Let's start with aerospace. Imagine a spacecraft capable of changing its shape according to its mission's needs, adjusting its wings for atmospheric entry, or contracting its body for protection against space debris. Shape-shifting materials could make this a reality. By altering their form and function, these materials could drastically improve the efficiency and safety of space travel. But the potential applications don't just stop at the final frontier. They also extend to the world of robotics. Robots, particularly those used in healthcare and disaster recovery, need to be adaptable. They need to navigate through tight spaces, adjust to unpredictable environments, and perform delicate operations. Shape-shifting materials could be the key to creating robots that can accomplish all of these tasks and more. Imagine a robot that can change its shape to fit through a narrow rubble gap in a collapsed building, or a surgical bot that can adjust its tools according to the procedure it's performing. And let's not forget about architecture. Buildings of the future could be constructed with shape-shifting materials, creating dynamic spaces that can change according to our needs. Imagine a room that can expand or contract based on the number of people in it, or a window that can adjust its transparency depending on the time of day. From homes to offices to public spaces, shape-shifting materials could redefine how we live and work. Even in the fashion industry, these materials could be game changers. Imagine clothes that adapt to weather conditions, becoming thicker when it's cold and lighter when it's hot, or shoes that perfectly mold to your feet, providing optimal comfort and support. The potential applications of shape-shifting materials are vast and exciting, opening up a world of possibilities. As we continue to explore and harness the power of these materials, who knows what other applications we might discover. One thing is certain though, shape-shifting materials are set to revolutionize our world. So, what happens when industries start adopting these shape-shifting materials? Picture this, an aerospace industry with shape-shifting materials, capable of withstanding extreme conditions, from the freezing temperatures of outer space to the scorching heat of re-entry. Imagine aircraft wings that morph in response to atmospheric conditions, reducing drag and saving fuel. This isn't just a scene from a science fiction movie, it's a glimpse into a not-so-distant future. In the world of robotics, shape-shifting materials could revolutionize the way we approach design and functionality. Robots could become more adaptive, able to navigate through tight spaces or change their form to perform different tasks. This adaptability would increase efficiency, reduce the need for multiple machines, and could even lead to breakthroughs in medical robotics. Now let's turn our attention to the field of architecture. Buildings could potentially adapt to environmental conditions, altering their shape to maximize sunlight during winter and minimize heat absorption in summer. The implications for energy efficiency and sustainability are enormous. In the automotive industry, shape-shifting materials could lead to cars that change shape for optimal aerodynamics, drastically improving fuel efficiency. Imagine a car that could repair its own dents, or a vehicle that could adapt its structure in the event of a collision to protect its occupants. Even the fashion industry could be transformed. Clothes could adapt to the wearer's body temperature, changing thickness or texture to provide optimal comfort. Or imagine a single piece of clothing that can change its shape and color to fit any occasion. The possibilities are truly endless. From telecommunications to healthcare, from manufacturing to entertainment, shape-shifting materials have the potential to disrupt and innovate. These materials could redefine the way we live, work, and play, bringing about a revolution in design, efficiency, and adaptability. The impact of shape-shifting materials on industries could be monumental, ushering in a new era of innovation. Shape-shifting materials are not just a fascinating concept, they're a reality. Just like an intriguing plot twist in a science fiction novel, these materials have stepped off the pages and into the realm of reality, taking our understanding of material science to new uncharted territories. Over the course of this video, we've delved into the captivating world of shape-shifting materials, unearthing the science that makes this seemingly impossible phenomenon possible. Through the manipulation of molecular structures and the ingenious use of external stimuli such as heat, light, and electricity, these materials can morph, contort, and adapt, changing their form, function, and properties in astounding ways. We've also ventured into the myriad of potential applications for these remarkable materials, from the fields of aerospace and robotics to the world of architecture. Imagine aircraft wings that alter their shape mid-flight for optimal aerodynamics, robots that can seamlessly adapt to their environment, and buildings that can transform to accommodate changing weather conditions. It's a future that's not as far off as we might think. The impact of these shape-shifting materials on various industries is profound and far-reaching. They have the potential to revolutionize how we approach design and problem-solving, offering unprecedented flexibility and adaptability. Indeed, they're set to redefine our understanding of what's possible, breaking down the barriers between science fiction and science fact. But with every scientific breakthrough comes new challenges and questions. How can we harness these materials in the most effective and sustainable way? What ethical considerations come into play as we continue to blur the lines between the natural and the artificial? These are questions that we, as a scientific community, must tackle as we move forward into this exciting new era. Shape-shifting materials are indeed a marvel of adaptive materials science, holding immense potential for the future. So, stay curious, stay informed, and keep exploring the wonders of science with us here on Brainiacata. Don't forget to hit that subscribe button and join us on this scientific journey. Every great magic trick consists of 3 acts, as do shape-shifting materials. The first act is the pledge, where we see the material in its normal, unaltered state. The second act, the turn, is where the material undergoes a transformation, responding to an external stimulus. The final act, the prestige, is the revelation, where the material reverts to its original form or morphs into a different one, leaving us in awe of its incredible capabilities. But how does this sorcery happen at a molecular level? Let's delve deeper. Shape-shifting materials are made up of polymers, long chains of molecules that can be manipulated to have different properties. When an external stimulus like heat, light, or electricity is applied, the bonds between the molecules in these polymers change. They may stretch, twist, or even break, causing the material to alter its shape. But this isn't an irreversible process. Once the stimulus is removed, the material can revert to its original form, completing the prestige. This ability to remember their original shape is what makes these materials so extraordinary. But the magic doesn't stop there. By tweaking the molecular structure, scientists can program these materials to respond to specific stimuli in specific ways, paving the way for new, tailored applications. From heat-responsive clothing that adapts to your body temperature to light-sensitive polymers used in 3D printing, the possibilities are endless. And with each new discovery, we're unlocking new chapters in the enchanting story of shape-shifting materials. So, let's keep turning the pages together. Stay tuned, stay curious, and keep exploring the wonders of science here on Brainiacata. Join us as we continue to unravel the mysteries of the universe, one video at a time. From the pages of science fiction to the labs of the real world, shape-shifting materials have come a long way. But have you ever wondered how these magical materials are made? Let's take a peek behind the curtain. The manufacturing process of shape-shifting materials is a delicate dance of science and technology. It begins with the design and synthesis of polymers, the molecular chains that form the backbone of these materials. Scientists use advanced computational models to predict how different polymers will behave, allowing them to engineer materials with specific properties. Once the polymers are synthesized, they are processed into the desired form, be it a film, a fiber, or a foam. This is where the magic happens. Using specialized equipment, the polymers are subjected to specific stimuli, such as heat or light, which cause them to change their shape. This training phase programs the material to respond to these stimuli in the future, enabling it to remember its original shape. The final step is testing, ensuring that the material behaves as expected and fine-tuning the process as needed. This intricate process wouldn't be possible without the technological advancements of the past few decades. From high-precision 3D printers to powerful supercomputers, technology has been instrumental in bringing the magic of shape-shifting materials to life. And as technology continues to evolve, who knows what marvels we'll be able to create in the future? The magic show has just begun, and there's plenty more to come. So, keep your eyes peeled and your minds open. The world of shape-shifting materials is full of surprises. Every great invention comes with its own set of challenges, and shape-shifting materials are no exception. While they hold immense potential, it's crucial to understand their limitations as we navigate the frontier of this emerging technology. One of the significant challenges in the production of shape-shifting materials is the complexity of their design and manufacturing process. As we have seen, these materials require sophisticated computational models, cutting-edge equipment, and highly skilled scientists, making the process expensive and time-consuming. Furthermore, the training phase, where materials are programmed to respond to stimuli, still lacks precision. This could result in materials not reverting to their original shape perfectly or responding inconsistently to stimuli. Moreover, the durability of these materials under repeated shape-shifting is still under investigation. How many times can a material change its shape before it begins to degrade? This is a question that remains unanswered. Lastly, the potential environmental impact of producing and disposing of these materials needs careful consideration. While we're marveled by the magic of shape-shifting materials, it's important to remember that every magic trick has its secrets and every invention, its challenges. But with every challenge comes an opportunity for innovation. As we continue to explore this fascinating realm, let's also strive to overcome these obstacles, pushing the boundaries of what's possible and shaping a better future. Having explored the science, potential applications, and challenges of shape-shifting materials, it's time to see these marvels in action. Let's dive into the real world and see how these materials are transforming our reality. First up, we have the world of fashion, where designers are using shape-shifting fabrics to create garments that change their form based on the wearer's movement or temperature. Imagine a dress that alters its shape or color as you dance, or a jacket that thickens as the temperature drops. Next, we delve into the realm of healthcare. Shape-shifting materials are being used to create smart medical devices that can change their form once inside the body. For instance, stents that can expand and contract, or drug delivery systems that can release medication when they detect a change in body temperature or pH levels. In the automotive industry, car manufacturers are experimenting with shape-shifting car bodies that can self-repair in case of minor dents or scratches. Imagine a car that heals itself just like a living organism. Finally, let's look at architecture. Shape-shifting materials are transforming the way we build, with structures that can adapt to environmental changes. Think of buildings that can change their shape to optimize sunlight exposure or to withstand different weather conditions. These are just a few examples of how shape-shifting materials are revolutionizing various industries. The magic of these materials is not just in their ability to change shape, but in their potential to reshape our world. As we continue to explore and overcome the challenges of this exciting technology, who knows what incredible innovations the future might bring? As we have seen, shape-shifting materials are already making waves in various industries, from healthcare to fashion, automotive to architecture. But what does the future hold for these transformative marvels? Let's indulge in a bit of speculation. Imagine a world where shape-shifting materials are commonplace. Our clothes could adapt to our needs, not just in terms of temperature, but even our mood or health status. What if our clothes could detect a rise in body temperature and change color to alert us of a potential illness? Or a jacket that could inflate into a protective bubble in case of a fall? In the realm of healthcare, imagine biodegradable shape-shifting implants that could perform complex tasks inside the body and then dissolve harmlessly. Or artificial organs made from shape-shifting materials that can grow and adapt as the patient's body changes. In architecture, imagine buildings that can morph to accommodate different functions or adapt to changing environmental conditions. A building's facade could change to maximize solar energy capture during the day and minimize heat loss at night. In the automotive industry, imagine cars that can alter their shape for optimal aerodynamics, increasing fuel efficiency and performance. The possibilities are as limitless as our imagination. As we continue to unravel the secrets of shape-shifting materials, we stand on the brink of a revolution that could redefine the way we live, work, and play. The future is not set in stone, it's shape-shifting.